Hello and welcome to another JUXTCast. This week, not coming to you from the city of the future, Milton Keynes, but a bit more of a remote flavour. So I'm actually in Bristol. I think we've got people in London, people in Dubai. So I'm Joe Littlejohn. I work in the consulting side of JUXT. I work across many JUXT consulting projects.
And I'm Aaron Knauf. I'm a platform engineer working for JUXT, working on a variety of projects over the years.
And I'm Mariusz. I'm a software engineer working for JUXT.
So Malcolm, our usual host, he's on holiday this week. He's in Italy, I believe. So I'm sure he's no doubt enjoying some good local wine and food this week, making the most of the Italian sun. So a bit of news. So Jeremy Taylor, our resident database and bitemporality expert, he's running a webinar. We'll link to the recording. So if you don't know anything about bitemporality and you're looking for an introduction, or if you're interested in how bitemporality is going to help you build fully auditable systems, then that's a good session to check out. And I think Jeremy has done a lot of research in this area. He's been working in this area for many years. So he will be an excellent guide to introduce you to the concept of bitemporality. So this week on the JUXTcast, we thought that we would dedicate this session to platform engineering. So a lot of businesses are thinking about developer productivity, security, compliance across their systems. At JUXT, we've been involved in platform engineering projects, and these things can be hard to get right at scale across many teams and when you have a large and disparate technical estate. So it's a hot topic at the moment, platform engineering. So we thought we would dedicate this session to it. And firstly, I guess if you don't know much about what platform engineering really is, Aaron, how would you describe, for the uninitiated, what is platform engineering?
Well, I guess for me, it's a evolution of DevOps. Sort of DevOps meets a product mindset. We move from a place where we kind of drifted into having a DevOps team who provided a service to the application developers and basically did all the scripts they didn't want to do. And now they build a product which provides the service that those scripts used to do poorly.
And how about you, Mariusz? What does how would you define platform engineering to someone new to the concept?
I think Aaron did a pretty good job defining it. But if I was to put it in a single sentence, I'd say it's about developing potentially internal platforms for self-service where the target customer is the developer.
So I guess one interesting phrase that's been thrown around for a long time, I think, is this notion, and I guess it came sort of from the DevOps mindset of trying to bring developers and ops kind of together as one. This phrase, "You build it, you run it." I'm interested. I think some people see this phrase as something that has had its time, and but I think in some ways that platform engineering is really a different way of looking at this phrase, "You build it, you run it." And I think that phrase is still just as relevant for teams and businesses trying to build a platform, build out their own internal developer platforms. I think this notion of "you build it, you run it" is still key.
Yeah, I think that's true. The thing that platform engineering brings is reducing the cognitive load involved in doing that whole "you build it, you run it" thing, where the the scope of things that an app team has to build and run for themselves has just increased over time with the advent of cloud compute, where everything's become virtualized. You don't only have to spin up VMs anymore. In fact, it's becoming more and more rare that you actually do that. But you have to understand all sorts of different networking-based concepts, and you also have to understand concepts around how to run a database securely. And there's any number of different things that you need to that you really need to get your head around in order to do a good job across a vast scope of what it takes to run a modern application.
Yeah, absolutely. And I think that the ownership, this notion of sort of ownership, you build it, you run it. I think that is still absolutely relevant. But hopefully, being able to achieve that in your teams should now mean that you actually need to know less and do less of all of the work involved in running it. But this idea of you still own the applications that you're shipping uh, is still absolutely key. But you may well be getting a lot of help to enable you to do that well from an internal platform team.
Yeah, absolutely.
The way we see it on, for example, the current project that I'm working on is about providing a foundation for people to build upon where most of the early problems are already solved for them. So it gets you straight away 50, 60, 70% there. And yeah, the rest of it is abstracted away for you.
Platform engineering, as I mentioned earlier, is a hot topic at the moment. We've got Platform Con, we've got many sort of active blogs dedicated to platform engineering. Gartner's talking about platform engineering. It's LinkedIn is awash with posts about platform engineering. Why do you think that this is? But in some ways, I think these concepts aren't new, and a lot of larger tech businesses have been attempting to do things along the lines of building out internal platforms to help their developers for a very long time. So why do you think there's a renewed interest now?
That's a very good question, and I confess I don't know the answer. Platform engineering is, I think, specifically the recent hype is around internal developer platforms, and I think platform engineering is maybe a broader concept than internal developer platforms. But developer experience is a concept that's become starting to get more airtime recently as well, and then perhaps for a little bit longer than internal developer platforms have. But and to me, a internal developer platform is really about putting that developer experience front and center and making it someone's primary role to enhance that.
Those internal developer platforms are probably the things that I'm sort of closer to than actual platform engineering at this moment in time, at least. So yeah, it's definitely cutting down the time a developer needs to ultimately deploy something to production. In theory, if it's done right, what they get out of the box is production grade and production ready. You just need to add the business logic on top. Then in terms of why now is the time where we're sort of seeing these things crop up. I don't know, potentially maybe with like Kubernetes and sort of technologies of that sort getting more and more popularity, it allows you to just move quicker and get further. And at the same time, you have the potential lack of skills on that side in your work and your workforce, right? So you have people who are, for example, good at writing code, but they don't necessarily know much about, say, Kubernetes, Helm, or anything, say, cloud related. And if you manage to build that into such a internal developer platform, whereby it's either abstracts it away from them, which probably isn't a good idea, but at least where the learning curve is sort of flattened, that they don't have to sort of go there unless they really need to, then you can utilize these people, and they can remain to be productive and feel good about what they're doing, and not really be concerned with these sort of other aspects of writing applications unless they really need to get into the details of those.
Yeah, I think the application teams they have a business problem to solve, and and in order to solve that business problem, they need to consume all sorts of different sort of compute infrastructure and facilities. Like they might need a database, they might need an event store. They're going to need to use all of these things. But unfortunately, to a greater and greater extent, this has meant that they need to take responsibility for all of these things. If they almost need to build them, the amount of code that it takes to spin some of this stuff these things are often a distraction from the main work that a developer, that an application team sees as their role. And platform engineering is really about taking away this guy's non-value generating, undifferentiated heavy lifting and making it someone else's main focus. And that someone else is going to do a far better job because they can do it at scale. They're going to do it for multiple teams. It's their number one job rather than being a distraction. And so you're going to get a far higher quality outcome, and you're going to reduce the cognitive load on both sides.
Yeah, I was just going to add to that on top of that, you may have systems within the bank that app teams are expected to integrate with. So, for example, something that would act as like an auth or a secret management solution. And if you bake that in, or if you can manage to bake that in into these internal platforms, then effectively the company can dictate the direction in terms of technology where they want to go, and the app developer teams don't really need to be that concerned with it if it's catered for that on that sort of internal development platform level.
I think it's interesting as well, Mariusz. You mentioned Kubernetes and the ability to provide Helm charts, or you might think of Terraform as another useful enabling tool for platform engineering, in the sense that I think a lot of these modern infrastructure tools are nicely modularized in a way that we now have a way to provide help by providing modules within that ecosystem. And they actually create some quite nice dividing lines, so that a platform engineering team might be able to help by providing Terraform modules, or they may be able to help by providing Helm charts. They may be able to help by providing, let's say, Docker base images. And I think we now have, in recent years, I think what's emerged is quite a few useful interfaces, if you like, for those platform engineering teams to provide help.
So I'm not sure that all of those things are what I would put into an internal developer platform. So I might use Terraform as a building block for building my internal developer platform, but providing Terraform modules as the interface, you start to run into abstraction problems and coupling problems there. If I provide a Terraform module to a development team, then I'm imposing on them the requirement to understand Terraform and to learn Terraform and to use Terraform. Whereas we can start to take a much more loosely coupled approach by providing the ability for software developers or application teams to describe their workloads using a declarative format, like perhaps a YAML file or something like that. The platform that I've been working on recently uses a JSON format, but I probably wouldn't use JSON again, simply because it doesn't have any comments in it. But once and what you achieve when you start to take this declarative approach is you move responsibilities around. If I want to upgrade from one version of some particular piece of infrastructure to another, that will often result, or maybe a different implementation. That will mean a change in the Terraform provider being used, and then I need to expose that out and have the consumers actually start to change their Terraform so that they use this different provider. So what they're getting from me might be a Linux container running somewhere, but or they might get a Linux VM. That's all they care about. They don't care about whether it came from Azure or Google or Amazon. And so when I swap out that implementation, why should they have to change their code? And so this is where tools like Terraform start to reach the edge of what they're good for, because they don't really provide a real abstraction over the underlying implementation. There's no concept of a generic Terraform VM, for example. I'm using VMs as an example, but it's probably not the thing you're going to be using. You're going to be doing all the time.
I think I don't know if you're aware of Humanitech. So it's an interesting entrant in this space, I think, which again, it's it's a direction in which the application developer begins to declaratively describe their application, and the specifics of the infrastructure that are introduced to serve their need are completely abstracted away.
Yes, exactly.
Yeah,
That enables both sides. That means the developer will they maintain a YAML file, a score file, in the case of Humanitech, and that describes what their workload, what their application actually needs from its infrastructure in abstract terms. It might say, I need a Postgres database. It doesn't say that I want an Azure Postgres database. It doesn't say that I want an Amazon one. It says I just want a Postgres database. It doesn't say that I want a tiny little development version or a massive geo-tolerant, super scalable production version. It just says I want a Postgres database, because that's really all I care about at that level. And then when you want to swap out that one implementation of that database for another, then you don't need to impact the application team in order to do that. The platform team can introduce a new version of how they do their Postgres clustering, or they can do a new version, an entirely different provider for their Postgres database, and it's largely transparent to the application team. Certainly, they shouldn't need to change code.
and things like you touched on it a bit there, but things like the level of redundancy required in a certain environment, or the non-functionals that are expected in a certain environment. This might be something that the application team doesn't need to think so much about, if what they're describing is, well, we need to persist data here, so we need a Postgres instance, but we don't know how that is managed in this environment, and the non-functionals they might not need to think so much about. So, I mean, one thing that's maybe a kind of an interesting topic, I suppose, is this question of, when building out an internal developer platform, what is the right way to think about adoption? So, is internal tooling that is being provided to help developers, is the right approach to attempt to help developers where they are, and try to look for ways for a platform engineering team to do some of the heavy lifting and provide tools and things that can help? Or is the job of the platform engineering team to build out an all-encompassing developer platform that effectively must be used in its entirety? So I just wonder about the I think maybe some platform initiatives of the past might have been to create a very bespoke and all-encompassing platform, and maybe we might see an approach, that alternative approaches applied these days, that don't necessarily require full buy-in. So I wondered about what which of those two approaches you've seen work well or not work well.
That's interesting. I think it mostly depends. Depends on the setting. Depends on type of development people are doing. In our current setting, what we have is you could describe as like a very sort of solid core that is non-negotiable. The tech choices have been made there, and people just need to get on board. And that is basically because the company chose that direction. And then a number of sort of smaller, almost like satellite solutions around it, where you can pick and choose that still ultimately interface with the core solution, as you like.
I think for me, it's about making sure that if you're going to solve a problem, you take it off the developer's plate. It's no longer their problem to solve; it's yours, and you've solved it for them completely. So, and so so what we did with a platform that I'd built over the last few years was to basically say that if you have a 12-factor app that has no persistence requirements, then we can provide a complete solution for you. We can we build a platform that will host your 12-factor app. Of course, when we say no persistence requirements, that doesn't mean that you don't have a database, but it means you're not allowed to save files to the local disk, right? And we never had any intention of providing a database. That wasn't our game. But so what we did is we just got out of people's way. However they wanted to access their database, that's just not a problem we're solving for them today. They do what they always did. But just because we can't solve that problem doesn't mean we can't solve this other problem. And so the key thing there, I kind of think of it as the interface segregation principle applied in the large, where the interface segregation principle states that if I want to adopt a method, I shouldn't have to depend on an interface that brings along a different method that I don't need. When applied to platforms, it's like saying if I want to use this platform for deploying my 12-factor app, I shouldn't also have to get this really crap job that they've done of their database. I should, they should provide the thing they do well and don't bother me with the thing they don't do well.
So there is, I guess, there is still some essential choice within the engineering teams, and I think this is an interesting question, isn't it? Because a lot of modern approaches to platform engineering, I guess, are about treating these internal your own internal developer platform truly as a product that has an audience and has customers, if you like. And I think the presence of some kind of choice within engineering teams of whether they're going to use your platform for this or whether they think that the help that you're providing in a certain area is useful to them, that can be quite a good something to drive you to actually create useful systems if there is some choice.
I agree. I think that for me, certainly in the early days of a platform, having the ability to test whether you've actually done a good job, to measure your own performance as platform engineers, to measure the success of your product, you need to have some optionality. People need to be able to vote with their feet. If they otherwise, you go, oh, everyone's using our platform, we must be successful. But in reality, everyone's cursing your platform.
I guess also the platform engineering team actually has a really good opportunity to influence the engineering culture within the business. And hopefully it's a team that's put together that really understands the engineering culture in some kind of aspirational way and knows where the engineering team should be taken in a way, and looks at the best things that are going on and tries to bring those techniques into the platform. It's probably no coincidence that you, within the system that you had been working on, that you chose the 12-factor app as the kind of application that you would like to support, because there were some characteristics of this that you felt this is actually a good way to build things. And so if teams are coming to you and they're not structuring their applications in that way, and they could be, they probably should look at your system and think maybe we should be using that kind of inspiration of how we should structure our applications.
That's absolutely true. I do personally think that 12-factor brought a lot to the table, especially as we moved from monoliths to microservices, and that opinion definitely was reflected in the design of the platform that I built. However, I think it's also really important to be aware that although, I mean, I have opinions about all sorts of things, but in my role as a platform engineer, some of those opinions are just not relevant. So the opinion about the 12-factor thing, that has to pay for itself. And the way it did pay for itself is that we brought zero downtime deployments to the table. If 12-factor brings with it a kind of a contract that is key to enabling zero downtime deployments. And so we were able to do zero downtime deployments of the underlying platform while applications were running on top of it, and the applications will be available to business the entire time. And as well as that, we basically brought zero downtime deployments of the application themselves to the space, and that was virtually free. I mean, it's never going to be entirely free. There's a discipline that you have to apply to zero downtime deployments. But the heavy lifting, as far as the code and the architectural changes required, were kind of that's what that opinion brought. That's how that opinion pays for itself.
But I think it's just one example of how putting together that platform engineering team, or building an internal developer platform. It's an opportunity to propagate best practices and get people together that have some good ideas about how teams should be working. And those things can influence. Just the very fact that there is help available if you follow this path can actually guide people towards coming around to that way of building things. And of course, there will always be exceptions. And the 12-factor app is a good example where there are many applications that actually may not benefit from being written in that way, or can't be for one reason or another. But actually, there are a very large number of applications that can be and should be.
Actually, it's funny you should mention that. We made a foolish mistake in the early days of building this platform, and we decided, we've got this great platform, let's start running everything on it. And we started running build agents on it. But without stopping to think that, hang on, a build agent is in no way a 12-factor app. And so there was we kind of really got kicked in the ass by this mistake when we were running a build on a build agent that was on our platform, that was deploying our platform. And and we took down the node that the build was running on in the middle of the build. And we completely destroyed all of our Terraform state files, and that took some work to recover. Fortunately, that happened in dev, and we were we were nowhere near impacting actual developers' lives. But that was a lesson.
Yeah, builds can't be killed seamlessly at any time. So, assuming then that there is some, we've talked about optionality and that actually that kind of can be a good thing. It kind of introduces the question, especially for larger organizations with lots of lots of departments, lots of teams. It does introduce this question of, if there is some choice, what are some good strategies for adoption? Mariusz, I wondered if you had any ideas about what have you seen work around adoption?
What we, for example, have done, whereby our product is effectively the product that the platform serves you, the unit that people get. You can think of it as like a sort of starter services, and then in a larger context, like starter systems. So in order to, for example, like get buy-in, we launched sort of fairly small, and we open it up to other developers within the company, and they could contribute in. They could raise any sort of queries, questions. Effectively, we arrived at the best way of doing things together. I mean, we were the ones who sort of like took direction on it, but the idea was that we would always be open and open-minded about what is the best way of achieving X and Y. And then it was basically the question of finding your first clients. Wasn't difficult to find the first clients amongst the group of people that basically helped contribute to what this thing should look like and how it should work. And then, interestingly enough, it was like a long pause where there were more and more people sort of using it, but no one was really sort of using it in production yet. And effectively, it sort of like got to a point where it was almost like a queue of people, and we knew that the minute the first people land in production, first clients land in production, the rest will just follow. And that has ultimately materialized. The pickup was sort of slower than I thought it would be, but the minute that has happened, like the floodgates opened, and literally everyone started using it. And I think now we're literally on track for the current platform to be the mandated default choice in the company.
And what do you think works best as a way to get teams onboarded? I mean, sometimes, of course, if you think about internal products, there is sometimes a bit of a natural problem, right, with these internal initiatives not being well documented. You know, you touched on developer experience, Aaron, and things earlier. So I think that's one thing that we've seen, right, is that this internal developer experience, whether it's really good documentation, a good model for contributions and a kind of bit of an open source mindset, like these things are essential to get teams onboarded, and they can't really be just an afterthought.
No, absolutely. I think documentation is, outside of the quality of the thing itself, is probably like maybe the second most important thing. Some people would argue it maybe is the first, but then you can't have, if you don't have a quality product, doesn't matter that you've got quality documentation. But ultimately, yes, you will have to support your clients, and in order to, like, if you do a bad job at documenting it, you will not be able to scale your team with client demands just to sort of have people to take tasks on. So, for example, in our case, we involved technical writers, and they actually helped out quite a lot, because developers could just effectively document stuff from a dev perspective, and they took it and turned it into, well, actually really beautiful, really readable documentation, and that helped a lot. So then there's the culture of support. Like, if something is documented, and people always prefer this sort of like face-to-face approach rather than reading documentation, unfortunately. Like, most people will still come to you and effectively almost like nag you for an answer, even though it's right there in the docs, right? So it's almost like there's an aspect of a culture in terms of supporting these clients, that you always sort of make them fall back to the docs, or almost make them find the answer themselves, and sort of don't give in too easily.
Yeah, that's where maybe a bit of a just like with other products, right? People are using SaaS products and other kind of good quality tooling of all kinds, and usually the actually reaching out to a support person is kind of a last resort, right? You want to be able to solve your problem yourself, not raise a ticket and wait for something. And so I think that should be the goal, right? That whether it's that you're really encouraging people to approach it in that way, that it's a self-service thing, and if they can't self-serve, there's something kind of not working quite well here.
You would certainly hope so, right? And I mean, we've seen sort of the broad spectrum of clients. There are, for example, people that have basically taken it and went all the way to production, and we actually never heard from them at all, and we just find out that they are in production because it's like got flagged up somewhere that this team has gone to prod. And on the other end of the spectrum, you will have people that will, regardless of how explicit or clear you make the documentation, it will not be explicit or clear enough. And oddly enough, like, this is actually a reasonably, it's a topic that reasonably often comes up, whereby there is a case that someone sort of didn't get something, or it wasn't obvious, and like, oh, do we need to change the documentation? And you'll never be able to like arrive at a situation where 100% of your clients will just get it. You shouldn't, that shouldn't sort of stop you trying, but you got to be, you've got to draw the line somewhere, right?
Sorry, I was just going to say, I think it's also really important to understand that when people come to you for support, that's a real opportunity to understand their mileage on your system, and and you're not going to build the right platform if you don't have that touch point. So providing absolutely stellar support, it's a real boost to the developer experience, but it's also a real boost to the platform team as well. And although there's a balance, you don't you provide too good sort of hands-on face-to-face support, and you can create a learned helplessness in the in your consumers, and that's also makes a rod for your own back.
I'm interested. Often products have. If you're thinking about bringing a new product to market, you're no doubt people are going to be thinking about sort of metrics and how to measure the success of that product. And it might just be purely financial, but there'll be no doubt certain leading indicators of whether that product is doing well. So how do you think businesses should be measuring the success of their platform engineering efforts?
So I was at I think it was DevOps Days a year or two back, and this was just as the whole internal developer platform hype was kicking off, and the and I had a whole bunch of vendors of brand new products come to me, and they were trying to sell me on this idea I should buy their portal, and they would. One of the key selling points I always brought was you'll be able to measure your developers' performance. You'll be able to figure out if they've got if they're adhering to your policies, if they've got the right level of code coverage, if they're for me, the response that I always had was, I don't want to measure my developers. I want to measure me. I want to know if I'm providing what my developers are looking for. And you could argue that on the one hand, the purpose of building this tool suite for your developers is to make them better at delivering for the business, and so there is a sort of a second order outcome of measuring the developers' performance. But the first order outcome for me is, what do my developers think of the platform? How much are they getting out of it? And so the approach that we're trying to take with the project that I'm working on at the moment is to, first of all, make the work visible. And the work that I'm talking about here is the work that developers have to do. For me, there's two kinds of work developers do. There's this inner loop, which is their code, build, test, push. That's their value generating loop. That's where they build business features, and that's what they get paid for. And then there's a huge amount of stuff outside of that that's as a distraction. That's all of that sort of non-value generating, undifferentiated heavy lifting or toil that they spend a lot of time on. And when you build your platform, the moment you launch it, you're wanting to launch early, so you're coming up with a minimum viable product, and the moment you launch it, what you want to get is you're not going to have it doing everything for them. And if you say I'm going to automate one of those many things that you do, then you can launch your platform, and they'll say, "Yep, it's done that one thing. Great, with success, we can go home." But at that point, you have no visibility of all of the other things you don't do for them. So we start to look at, so what are the set of things you do to take an application from concept to production? And in some organizations, that can be a large, involved, very long process. And there will be many steps, and you won't automate all of them on day one. But having a view of how many of those steps you have automated, measuring how long it takes the developer to go through that full process, measuring the difference you can make to that full process as you start automating like one step or two steps or three steps, then that's at that point you're starting to then be able to measure the success of your platform rather than the success of your developers.
What we found really difficult, for example, on the topic of measuring success and specifically measuring the metric that was picked was how many man hours, man days would a given feature or a combination of features ultimately save. And when we would talk informally to clients, they'll be very open. They'll be like, oh yes, this has actually like saved us, like this many man days, blah, 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 blah. And when we asked them to actually sort of put pen to paper, whereby, higher management effectively wanted figures, and they started putting it down, they were like, okay, but we can't actually tell them that. We can't tell them that, like effectively now, I'm asking for like 10 more people, and I'm actually here, I'm telling them that, well, I could do with just 5. Right. So there's a good balance that needs to be struck there, I guess.
Yeah, how do you explain that 3/4 of your work was spent on sort of pointless toil that didn't contribute to achieving your application's goal up until now?
Yeah, so this by feature approach, I think works best, whereby you effectively sell your platform by how to put it, by covering effectively what integrations you cover for out of the box. What the fact that someone gets like CI/CD integration that they don't have to effectively invest time in, and it's about what the developer doesn't have to do anymore if they choose this solution over effectively starting from scratch.
But you can also look at things like degrees of consistency of application of policies and standards, right? So one of the in large enterprises, one of the things that's difficult to do, you might go out to market and you might hire absolutely top talent, and you have dozens of teams that are, let's imagine, all awesome, and they all do all of the things that they're supposed to do in order to be compliant with regulations and with policies and with standards. But how do you know that? How can you assert that? And you can't go around and audit every single one of them. The overhead of for all concerned is too much. So you have to start going, okay, so how else do I assert that that standards are consistently applied? You have to narrow down and focus in on a few ways of doing things, and so that you lessen your audit load. And so when you start able to have your platform just basically do some of these things for people, then it's only your platform that needs to be audited, rather than every team's own solution to that problem, right? And so degrees of and so you get this ability to assert at scale that yes, your organization does consistently adhere to this requirement.
Truly does become impossible when you have a large number of teams all taking their own approach to doing these things. Whether, I think obviously there's a kind of a first step on that journey, which is making those requirements and the things that you expect from teams very clear. But as you say, Aaron, there is no way to truly assert that your system is compliant. If there are certain cross-cutting rules or requirements, they might be around handling authorization correctly. They might be around data handling. They might be related to GDPR or other sort of privacy legislation. And these are things that you do need to be able to assert with confidence across a platform. And the only real way of doing that is to bring the kind of consistency that you can get from taking those decisions away from engineers. And they don't really need to see this as something that is restricting what engineers can do, because I think it can be very freeing to have some of these things just done for you. It can be very freeing to have the team able to have the freedom in a way to focus on their own domain and not have to think about all these things and be concerned about whether they've taken all the right steps to be compliant.
Yeah, if I even just take the example of a CI pipeline, over the years that I've been doing the continuous delivery, the number of things that people expect to be in your CI pipeline has just grown. Every year there's something new that they want in there, and you will launch a new application, and getting all of those things into that CI pipeline, it's a non-small job. We used to talk about iteration 0, where your first sprint was spent getting your path to production sorted out. But if you have to write the code from scratch to put all of the checks that people realistically expect to be in a modern CI pipeline, and it's more than one sprint of work. And you can basically fast forward all of that by cookie cuttering that out, and that's a huge benefit. No developer wants to write that over and over and over again. They might have liked doing it the first time. They might like to make sure that what they have is fit for purpose and allows the flexibility and extensibility that they need for their application. But beyond that, they don't want to spend all their time doing that.
So where would you say is a good place to start if people want to, I guess, a couple of things. Firstly, where is a good place to start? And then also, what are some pitfalls to avoid if people are kind of starting on this journey and they want to, draw on the experiences of people that have built these systems before, built internal developer platforms, or been involved in platform engineering? How can they get started?
I think Aaron mentioned something at the beginning where, an MVP with a specific case or cases that you cover for. You're not going to be able to build the whole thing in one go. It's probably better for it to do one thing but do it well, rather than do multiple things and not necessarily do it well. Things you probably have to watch out is like some, depends on the design and so on and so on, but effectively, conceptually, some form of a contract whereby what you produce at the beginning, at that MVP phase, when you're going to get people initially, onboarding the early adopters, that you sort of internally stick to that contract as well, so that when you move away, when you start to build on top of what you had and you release the next version, they are not sort of left behind because, now I need to like re-architect as I'm growing, right? So I think you need to be very careful there.
And specifically, I mean, you mentioned, Aaron, trying to really look at the developer, the developer's job in your organization, and where is it that they are spending most time? What are the different activities that they're doing, and using that as a way to identify where you can provide the most useful help. But in your experience, where is a good place to start? Specifically, what technical challenges would you say are good to take on in the platform rather than in the hands of the engineers? If you're looking to build an MVP and you have a team together, you're looking to maybe quickly start on this journey.
So I don't know if there's a one size fits all. Here's where you start. So I've started in a few places. We started on one platform by basically saying we can see that when people want to deploy, so it's easy enough to get a local dev environment up and running, but then setting up all of the environments for that you need to then promote your application through, and then finally on into prod. The setting up of all of that infrastructure was a huge job, weeks of work, and so we built a platform that took that off their hands and collapsed that weeks of work down into less than an hour, and that was by looking at that specific situation and going, well, this seems like low-hanging fruit. Well, when I say low-hanging fruit, it wasn't easy to solve. It's not that we achieved that straight away, but that was where the money was, basically. Then the other part of the problem is looking at, okay, so we provided a runtime platform that pre-provisioned all those environments, and so that the developers didn't have to go through to figure out, like, how do I run a Terraform script to get all of these things up and running. In fact, when we did this, we pioneered the use of Terraform in that organization. The APIs required to actually even use Terraform were not exposed before we started. So then the other part that we always had in our sights was like, okay, now we've got the runtime platform. Now we need the actual path to get there. right? And that was and that's that path to get there is where we started the next time we did that, where the runtime platform was not the problem that they had there anymore. There was a kind of a Kubernetes as a service environment that's available to everybody, and so rebuilding that seemed to be a bit pointless. But there was a large number of hoops that you jumped through in order to obtain all of the necessary Kubernetes environments, namespaces, and not just the infrastructure either. The all of the various steps you have to go through to just get access to the various tools and resources, and it's non-trivial. Like, where do you put your secrets? Where do you put your all of these things? The way that the developer workflow went was that they would spend a few days. They want to launch a new microservice, right? They would spend a few days casting around to find where are all the docs, because this stuff changes over time. There's always work in this space that people are producing new services to help you do that. Each one of them has their own wiki or their own self-service portal. And we looked across all of this and we realized that half the job was just in presenting all of that documentation and to one consistent, like, here's how you do it, and then starting to automate those steps. There's no reason that you have to go and manually raise three entirely separate requests for three entirely separate Kubernetes namespaces. There's the other part of it was when teams were surfacing, like, here's this great thing we've built that lets you get hold of a database or a Kubernetes namespace or this or that. Every one of them presented it entirely differently to the next one. And so we kind of treated our platform as the integration hub for all of this. We provided a consistent way of people surfacing this, all of this stuff. Instead of going copy paste my example code, we go click this button and it will template it out for you. So that was the approach we took to the more recent foray into this space, and which is, as I was saying, entirely different to the previous approach. And I think it really is very situational.
I guess you can kind of get started, can't you, if you see it templates and examples are, in some ways, you don't necessarily see this exercise as full automation from day one. It may be that you take on the automation of some areas. Then maybe the runtime platform is where you focus, and then for the developer experience to get to that runtime platform, you say, right, well, the first thing that we're going to do in order to provide some help and shorten that journey, we're going to do it through getting the documentation together in a consistent place, or we're going to do it by providing good examples and templates, but we're not going to do it by building systems that automate those processes. So maybe that's can be a useful way to bring some value if initially.
Yeah, so we kind of see it as a progression, and each different step in the process follows the same progression, where we say, okay, so to start with, we just list out. So if we say that you've got our goal is to automate iteration 0, so that you've got a path to prod, you've got hello world deployed and working in prod like 5 minutes after you decide you need it. That's then we go, okay, there's 20 steps to get there. For each one of those steps, the first useful thing we can do is just give them a link to the docs. We say, okay, here's the 20 steps, list out those 20 steps and give the links to all the docs. That saves a day or two of work for most developers to cast around and figure out where all that is. It's a small step, but each one of those steps can then, we go, okay, so first we create a link to the docs. Secondly, we actually raise whatever request there is for them. The third level of progression might be that we just do it for them. And so you can, those first two steps can be quite a small amount of work, and you don't need to do that to all of your to everything on your definition of done here in order to start providing value. And so it's for us, it's very much, we understand that there's a long tail of work to automate all the things, and we want to keep sight of all the things and where we are on our journey towards automating them, but we also want to be providing incremental value along the way.
So, assuming then that in your organization you've built out this internal developer platform, things are going well, and you've really improved the productivity of engineers. You've got some of these other benefits. You're pleased that you've got some really good assurances around some of the non-functionals around your platform and compliance, things like this. I guess one pitfall is that, I think we see this in some of the kind of older, long-standing internal, what you might consider internal developer platforms. I guess one pitfall is that you kind of think, right, our work here is done, and your platform actually, it kind of pins the technical approach of the organization to a certain point in time. And 5 years on, that's looking a bit sort of showing its age. And 10 years on, it's everyone's hating it, and it's really holding the organization back. So what do you think about how to approach this problem of kind of continuing to evolve your technical approach, and not allowing your platform to become the thing that the thing that people loved, but then eventually they grow to hate, and is really actually showing its age, and everyone is really looking at other techniques and thinking, oh, wish we were doing that.
So I guess for me, part of the solution here, so we haven't really spoken about the concept of golden paths yet today, but that's a key concept for us. Our role is to provide a golden path for developers if they want to if they want to solve a particular type of problem that we have a solution to. The path will be paved with gold to get there. Right? It's going to be really easy for them, super slick. Now, the key to your platform not becoming a golden cage is to create a golden path for enhancing the platform. So if the developer comes across something that they don't where the platform doesn't do that thing and they need it, or where it just does it in a way that they that is not working for them, then providing a golden path for contributing enhancements is a key part of it, right? So at that point, your golden cage is no longer a cage, because there's a golden path out of the cage, right?
I think as well there's a little bit in terms of the now good boundaries between the application developer and the platform. I think I think of a lot of large organization platform engineering exercises where they may go too far in terms of restricting the application developer. It may be that the internal platform attempts to truly solve the entirety of the problem of building and running applications, and it almost becomes to the point where what the developers get to do is put some code that must be written in a specific language into a text box, and everything from this point forward is done for them. And I think these are the kind of, and all of the services that they rely on, the way that they may discover those and interact with those, they are all of these problems are solved by the platform. But it really truly requires a whole organization buy-in. And all of the development approach, the languages that are used, they're all dictated by the platform. And I think these days, I think we have some better boundaries, if you like. We have some good ways to package applications such that these internal developer platforms can actually support a healthy amount of diversity in the application space, so that application engineers don't need to feel that the platform that they're using restricts everything about how they build applications.
In larger organizations, especially banks, which language stacks or which frameworks you can use is driven by the company. You, as a developer, you can make a case that, well, I would like to, I don't know, bring Rust in, or whatever. But bringing in technology typically has that sort of penalty that once you bring it in, once you do something in it, it sort of tends to stick around. And if it isn't something that where the job market can provide sort of enough support for you, then you're sort of stuck. And I certainly worked in companies where that was the case with Scala. They got sort of burned by it because they got Java developers to write Scala, which wasn't actually sort of proper Scala code, and well, therefore Scala is bad, and now we want to get rid of Scala, right? But I'm sort of digressing a little bit. With technologies like Kubernetes, containers, and so on, what you're deploying typically is sort of, well, there are multiple levels of abstraction in between, right? Therefore, as long as the language and framework is supported by the bank, as in it's maintained, there are updates for it, et cetera, et cetera, et cetera, typically you shouldn't have any issues with introducing any additional languages or frameworks. And on the topic of what would be the sort of the right size for the thing you deploy, whether or not you allow the developer more or less freedom. Again, I don't necessarily see it as like a sort of one thing that has to happen. Like at the moment, for example, we're doing starter services where you get the code, you get the Docker files, you get the Helm charts with all the Kubernetes setup and so on and so on. You're free to change it any way you like, provided you adhere to the architectural rules and so on and so on. And those are again decided by the company. And on the other end of the spectrum, you get things like serverless functions, whereby you do really just provide the little bit of code that you run. And in fact, even though it still uses Helm underneath somewhere and so on and so on in Kubernetes, that is abstracted away. The documentation doesn't even mention it because as a user, you're not meant to be touching that bit. So I think there is wide enough scope to have a platform that caters for all of these cases.
So I think what you're saying there, Mariusz, is absolutely right. And it goes beyond just banks. Like any large tech company, they often they'll start to say, like, we'll support this tech stack or these few tech stacks, and but the problem is not so much that that you can only choose a language that's supported by the company because that's what the company wants to do. The problem is really that the company made that decision, invested into that tech stack, and now they're a little bit heavily invested, and they can't really easily change it. And even happens at smaller scale. You'll have a team that says, okay, they look around the organization that they're in, and they say, okay, so this is the platform that we're starting from, and they'll build a scaffolding on top of that platform to let themselves get ahead. And then they become a prisoner of their own scaffolding. The amount of stuff that they've invested in that little scaffold that they've built up, they don't want to go through all of that pain again, and that starts to hold them back. And so the key thing here is about building things so that they are loosely coupled, so that you can change your mind about one thing later without changing your mind about everything. And because like I was saying this at the start, the reason that you're stuck with certain language choices or technology choices in many organizations is because that organization, it just doesn't have the choice. They couldn't do a different thing if they tried.
The other thing you can do as well is like stick to either open standards. That's not to say that every open standard is a great standard. Obviously, you have to do some vetting and so on. But a good example of this is probably telemetry. So auth is pretty much the standard for telemetry these days. Not that you can't do something else, but when we built our platform, we decided to stick with auth. And I think initially in the early days we were using something like Jaeger because it came bundled with the solution that we were using. But ultimately, like, it doesn't really matter what the centralized solution for tracing will use, because we're using effectively a transparent standard for that aspect of the platform.
Actually, that's a great example, and I've got a similar one from my own experience. Where a previous organization I worked in, we part of the platform was a library for doing logging, and so along with that library came a few hooks. First of all, the library was only available in a couple of languages. And secondly, their Java implementation of that library had a whole bunch of thread locals for storing various aspects of your of logging state. And the thread locals thing took your so the fact that it was available for Java locked you into using Java as a language. The fact that it used thread locals then locked you into using a one thread per requests concurrency model, which in modern development that's pretty archaic. the non-blocking I/O and coroutines and those kind of things are just not on the cards for that. And I'd contrast that against the approach that 12-factor takes, and it's this. Where 12-factor just says write your logs to standard out and treat them and treat your logs as an event stream, and that very clearly leaves it up to the platform to figure out how to get your logs from standard out to wherever they've got to go. It means that your application doesn't even know where that has to be. It's an absolutely beautiful piece of abstraction. That like standard out is available to every process, regardless of operating system that you're running on. It really is a extremely loosely coupled versus. I have to have a Java application that's using this particular library, which carries with it this particular thread model, and it now also needs to know where to send those logs to, and that's you can see the difference in coupling there.
And I think that's a great point, actually. Often it really is about standards and the problems with the business effectively being pinned to a point in time of one very bespoke and different solution and implementation that the business came up with at that time. It's often rooted in the problem that instead of looking at what are standard and best practice ways to do this, the platform was an attempt to create an entirely bespoke and different way of doing these things. And I guess that's one difference now, is that things like OpenTelemetry and other, a whole variety of different standards and interfaces that have now reached a level of maturity, and enough of this ecosystem is covered with similar kinds of interfaces that I guess have been born out of the era of cloud computing and things like metrics and tracing becoming kind of really like standard techniques that everyone is using. We've actually got to a level of maturity of some of these standards that they're all there if you just sort of find them and build upon them. And then it's funny, isn't it? Because as much as some of these standards have matured and appeared and are now really good things to build upon, some of them, in some cases, it's about going back to things like standard out instead of looking at all kinds of strange and funky ways of logging or logging to lots of different files or things like this. Is actually about simplifying and going back to say, right, applications should produce logs to standard out, and therefore that then means that the platform itself can worry about where those should be directed.
But it's only because the solution to the problem is now available elsewhere, almost like sort of shift left sort of thing.
Yes, exactly, because we now actually know that we've got a whole load of solutions now for aggregating logs and shipping them and ingesting them in other ways.
Yeah, that has become somewhat commoditized these days. Yeah. Okay,
well, it was great talking to you guys. Thank you very much, Aaron and Mariusz, for putting aside the time to chat with us. We'd really like to, keep the conversation going. If you've got thoughts about platform engineering, tweet at us at JUXT is our Twitter handle. Comment on this video on YouTube. Get in touch with us at info@juxt.pro if you're interested in building out your own internal developer platform and you'd like some advice. So thank you, Aaron and Mariusz, and see you next time.